Alright, hello all my Geometry Concepts students. Sorry for the late posting here. I'm learning new software. I didn't realize processing would take so long to get things up on YouTube. Alright, so for our first lesson we're going to be looking at something called trig functions. Trigonometry functions, essentially. Alright, now it's going to be very useful to have one of these. Now if you do not have one, most phones, if you have a calculator on your phone and you turn it sideways, it'll turn into a scientific calculator. And what you're looking for is sine, cosine, and tangent. You're looking for these three buttons down here. Once again, it's sine, cosine, and tangent, because those are going to be the three functions that we're going to be looking at. You can also go online and type in Google scientific calculator. It'll come up right in the Google search, and you can use the one there as well. If you're having a problem getting a hold of one, let me know in our next Zoom meeting, and we'll try to come up with a solution. Okay. So we're going to start off with 8.3. A little warm up. We're going to do a 2 divided by 3. So if you do have a calculator handy, you can just plug that in, and this is approximately 0.67. Approximately 0.67. For the next one, 7 divided by 24. That's approximately 0.29. 0.29. And 8 divided by 9 is approximately 0.89. About like that. Okay, so just a little review about division. We're going to move down here. Now, these ones down here. Remember, if you put 0.8 over 1, you can do that. That's the same as 0.8. Now all you have is the cross product. So you might remember that from 7th and 8th or algebra. 7th or 8th grade or algebra. So remember, you're just going to multiply these two and set it equal to multiplying these two. So this is going to become 0.8x equals 5.8. Like that. And then to go from there to solve that, I'll tell you what I did there. You just divide by 0.8. Divide by 0.8. Just like that. Those cancel. 5.8 divided by 0.8 is 7.25. Alright, and then if you wanted to go back and just do a quick check, 5.8 divided by 7.25 is 0.8. Okay? So if you want to pause the video and try the next two on your own, please do so, just so you can do a quick little check. Alright, I'm going to go through the solutions. So I'm going to put this over 1. I'm going to look for my cross product. So this is going to be 0.94 times 8.5 equals 1 times x. Like that. And if we put 0.94 times 8.5, we get about 7.99. And 1 times x is just x. And then if we go through 7.99 divided by 8.5, we get 0.94. So that works out. It's good. And for number 6, put that over 1. This is going to be 0.53 times 4.6. And that's going to be equal to 1 times x. So back over here, 0.53 times 4.6 is 2.43. 438. And that's what you should have had for x. Okay? So as long as you can remember how to do these, we're doing one thing that's kind of different. We're going to be introducing sine, cosine, and tangent, those functions, into equations that are similar to these. Okay? Now, for right now, the objectives are just going to use trigonometric ratios to find side lengths and right angles to solve real-world problems. We're going to hold off on the angle part. That's going to be our lesson for Friday, I think. Okay. Trigonometric ratio. Excuse me. The trigonometric ratios. This is something called SOHCAHTOA. Okay, SOHCAHTOA, and these are very, very important. All right, in the spelling is what makes this so important, because it's telling you the ratios. It's telling you the ratios. That, like up here, remember how these are ratios? Okay? It's telling us the ratios for sine, cosine, and tangent. So down here for sine, OH, we're going to put this, opposite over hypotenuse. Okay? And just as a little review, remember the hypotenuse is that side that's closest, or the side that's opposite from the 90 degrees. Okay? Cosine, that's AH. For this one, we're going to put adjacent over hypotenuse. Whoops. Okay? And then the last one, tangent, OA, that stands for opposite over adjacent. Okay? And we're going to use these ratios for these next problems, okay? And remember, this is a fraction. This is opposite is the numerator, hypotenuse is the denominator. Adjacent's the numerator, hypotenuse is the denominator, opposite's the numerator, adjacent's the denominator. Okay, turn the page. All right, so looking at this, whoops. All right, by the angle similarity postulate, a right triangle with a given acute angle. So a right triangle, remember, is measure of 90 with a given acute angle. So that means one that's smaller than 90, right? Is similar to every other right triangle with that same acute angle measure. So if this is 90 and 32, okay, the measure for all of these are going to be similar in the ratios, okay? The ratios are all going to be similar as well, okay? And so if ABC is congruent to DEF and XYZ, then BC, this one, over AC, so that ratio is going to be the same ratio for these, okay, if you use the same legs. And this is what it means. This is why SOHCAHTOA is so important. If you're a little confused with what I just said, this is our SO. Sine of A equals opposite leg over the hypotenuse. So if we look at this, the sine of A, okay, because remember the big A stands for an angle. Okay, the capital letters mean angles. Okay, the lower cases mean side. Okay, so if we look at the side of angle A, the sine of angle A, we look at the opposite leg, which is A, over the hypotenuse, which is C. So that makes a little ratio, right? You know, it's like when you're having a ratio to, like, you know, cows to chickens. You know, this is just lengths of two legs. There's still two numbers, and they form a fraction, okay? Just like if we go to the sine of B, okay, we're going to go to the opposite leg, which is B, over the hypotenuse, which is C, okay? And that's the sine. Cosine. If we looked at the cosine of A, so if we look at the cosine of A, okay, the red's going to be the cosine. We're going to look at the adjacent leg, so now that's going to be our B, and that's why B is on top over here, okay? Over the hypotenuse, which is still C, okay? And we're going to go through a couple examples, okay? I'm going to pause it for a moment. Okay, sorry about that. I don't know how big of a miss there was in the video. Hopefully there wasn't much of one. So, going off the idea of setting up these ratios, we're going to go down here. We're going to find the sine, cosine, and tangent of J, and the sine, cosine, and tangent of K. So if we're looking at this, let me zoom in here a little. So if we're looking for the sine of J, okay, first we have to find our angle J. There it is. There's our angle J. Okay. Now remember, I always write it out. SOHCAHTOA, just like that. So if we're looking for the sine of j, we're looking for the opposite leg. So that's going to be 60 over the hypotenuse, which is 61. So this is just 60 over 61, just like that. Okay. Now we're going to go to the sine of k. So the sine of k, there's our k, that's our angle k. We're going to look for the opposite leg, which is 11, over the hypotenuse, which is 61. So this is the sine of k is just 11 over 61. Okay? And remember, these capital letters mean angles. So this could be like the sine of 45 equals 11 over 61. Or the sine of 62 equals 11 over 61. Okay? Next, we're going to look at the cosine of j. So if we look at the cosine of j, so if we look at j. So that's our angle j, right there. Cosine is adjacent over hypotenuse. These are the two legs. They make up the 90 degrees, so they're perpendicular. So these are the two legs of the triangle. So the adjacent leg is going to be 11. So the cosine of j is 11 over the hypotenuse, which is 61. Just like that. Okay. You may see a resemblance here. Okay, don't worry about that just yet. Next is the cosine of k. So if we go to the cosine of k, we go to cosine. That's going to be the adjacent leg, which is 60 over 61. Just like that. Okay. Now for the last two down here, this is tangent. So when we go look at the tangent of j, that's TOA, OA. So that's going to be the opposite leg over the adjacent leg. Opposite leg over the adjacent leg. And remember, j is this angle right here. So you're looking for the adjacent leg to that angle. So the tangent of j is going to be opposite 60 over adjacent over 11. So this is 60 over 11. Okay? And then the tangent of k. So when we go here, we found our k. Tangent is opposite over adjacent, opposite over adjacent. 11 over 60. Just like that. Okay? Alright, let's turn the page here. Try, if you would like, try to pause this video and try these three on your own, and I will get back with you. Okay, so we're gonna solve this. So write the trigonometric ratio as a fraction as a decimal rounded to the nearest hundredth. So as a fraction, and then just recognize that it can be written as a decimal. So if we're looking for the cosine of a, we're gonna go here. Remember, the capital A stands for the angle, and remember SOHCAHTOA. SOHCAHTOA. So if we're looking for the cosine of A, whoops, let me get that down there. Sorry about that. So if we're looking for the cosine of A, we're going to take the adjacent leg over the hypotenuse. This is the opposite leg. Okay, the adjacent leg is here, so it's going to be 24 over the hypotenuse. That's 90 degrees. This is our hypotenuse. So maybe if you wanted to label it really quick, with a 90, this is a leg, that's a leg, and this is the hypotenuse. Okay? And so if we're looking for the cosine, it's going to be adjacent 24 over 25. And if you put that in your calculator, 0.96. About 0.96. Like that. Okay? Next, we're going to be looking for the tangent of B. So if we're looking for the tangent of B, we know that that's going to be the opposite leg over the adjacent leg. Opposite leg over the adjacent leg. So it'll be 24 over 7. 24 over 7. And when we divide those two, we get about 3.4. Okay? 3.4. And for the last one on the bottom here, we're looking for the sine of B. So we're looking for the sine. That's going to be the opposite over the hypotenuse. The sine of B, so we're looking for this one, is going to be the opposite leg over the hypotenuse. So it's going to be 24 over 25. which is about 0.96. Okay? Just like that. Okay? All right. So let's move on here. So let's go down here. So we're going to use trigonometric ratios and special triangles. Oh, those special triangles. But just remember SOHCAHTOA. SOHCAHTOA. And, you know, if we use special triangles, we're just going to be putting them into fraction form and seeing what cancels. We're not going to sit here and try to figure out lengths or anything, so don't get scared about that. All right. So if we're looking for the cosine of 30, so here's 30 degrees. We're looking for the cosine. That's going to be the adjacent leg over the hypotenuse. So the adjacent leg to 30 degrees is s square root 3. Okay? Over the hypotenuse, which is 2s. Okay? Just like that. Now what do you notice about this fraction over here? Notice that you can cancel those s's out, and when you cancel those s's out, then you're just left with the square root of 3 over 2. Okay? And then if you wanted to put that in your calculator, that is approximately the square root of 3 divided by 2 is about 8.87. Just like that. Okay? Let's go down here. Another special triangle. Okay? Remember, this is S. This is S. Does anybody remember what that's going to be? This is S. That's S. This is going to be S square root 3. Okay? So, we're going to use a special. We're looking for the tangent of 45. So remember, once again, remember SOHCAHTOA. Okay, so if we're looking for the tangent of 45, you can choose this one or that one. It does not matter which angle you choose. But we know the tangent is going to be the opposite leg over the adjacent leg. So the tangent of 45 for this triangle is going to be equal to S over S. And what is S divided by S? 1. So the tangent of a 45 degree angle is always 1. No matter if this S is 45 feet long or 2 inches long. The tangent of 45 is always 1 because the ratio of these two sides is 1. Okay? Alright, so on the back, your homework is go 1 through 6 for right now. 1 through 6. Please complete them all. It says find the value of each trigonometric ratio. Express your answer as a fraction in lowest terms. So make sure that you give me lowest terms, not a decimal. All right, so try this out. We have our Zoom meeting tomorrow. I will be posting those up this evening, making the meetings. And let me know if you have any questions. Thank you.